Hey guys, in case you're new here, I'm Miss Tyson. Today we're going to be talking about isotopes. So it's really important to understand what an isotope is because it's going to affect the atomic mass of the element, and in nature you're going to find different isotopes. It's not always going to be exactly a pure element when you find different elements in nature. So far we've only discussed the neutral atom. We've discussed an atom as it appears in the periodic table, with an atomic number equal to the number of protons, with an atomic mass minus the atomic number giving you your neutrons, and with electrons equal to protons. That is our neutral atom. Protons and electrons are equal, giving positive and negative charge, equal balance, so it doesn't have an overall charge. We found the neutrons in our neutral atom by taking the average atomic mass, subtracting the atomic number, and it gave us the number of neutrons. So the average atomic mass, if you're looking at your periodic table, would be the bigger number. And what they do to find that is they take all of the isotopes in nature, they average the weight of all of them together, and they give you an average. So you can see why if we're talking about a specific isotope, we need to know the specifics on that type of atom. So neutral atoms have equal numbers of protons and electrons, making their charge zero or neutral. Isotopes are a little bit different. Now their charges are still going to be neutral because we're only going to be changing one thing, and it's not anything with a charge. Remember, we can never change our protons. If we change protons, you've got a totally different element because the number of protons is equal to your atomic number. So if you go from, say, 1 proton to 2 protons, you've gone from hydrogen to helium. So we know we can't change the protons, but let's think about apples real quick as we talk about isotopes. Red Delicious, Granny Smith, Golden Delicious are all apples. They have different properties, different colors, different tastes, but they are all still apples. So isotopes are atoms of a same element, so like hydrogen, let's say. We can have isotopes of hydrogen that have the same number of protons, that gives the element its identity, but different number of neutrons. Now you know, protons and neutrons make up the mass. So if we change the neutrons, we change the mass. Imagine if you had everything in your purse and that made up the mass of your purse. If you took something out of it or added something to it, that's going to change the weight. Okay, so isotopes are going to be different atomic masses. Obviously, remember we have to have the same atomic number because that is our number of protons and that never changes. So the atomic mass indicated on a periodic table is an average mass of all of the isotopes that exist for a particular element. That's why it's a decimal, it's not even. Okay, so for isotopes, the first thing I want you to do is I want you to click on this speaker right here. It's going to tell you a lot of really important information about isotopes. You can see all of these atoms, they're isotopes of each other, but how do we know that? We know that they're isotopes of the same element because I notice in order to be the same element, what has to be the same? The protons. That tells you which element you have. I've got 1 proton, 1 proton, 1 proton. So all 3 of them are hydrogen because hydrogen has atomic number of 1. Now we notice something else. Electrons stayed the same. So our atom is still neutral. Our positive protons and our negative electrons are equal in each one of these. So if protons didn't change and electrons didn't change, what did change? You'll notice that our neutrons changed. We had none here, 1 here, and 2 here. So you've got all 3 are hydrogen, but they are all isotopes of hydrogen. What that means is all 3 of them are hydrogen. They've all got 1 proton, but they've all got different atomic masses. This one, we know protons plus neutrons gives us the atomic mass. Protons, 1, plus neutrons, 0, gives us an atomic mass of 1. And the second one, protons, 1, plus neutrons, 1, give us the atomic mass 2. Protons, 1, plus neutrons, 2, gives us the atomic mass 3. So all 3 of these are hydrogen. All 3 of these occur in nature at different times, but all 3 of them have different atomic masses, making them isotopes. So remember how we find the number of neutrons? We do atomic mass minus atomic number. And you can see here, atomic mass, 3, minus atomic number, 1, is 2. We have 2 neutrons. Atomic mass, 2 minus atomic number 1 gives us 1 neutron. Atomic mass minus protons, 1 minus 1 is 0, and you notice we have 0 neutrons. So the way they write this is they'll take their atomic mass, they'll put it on top, and it'll be a bigger number, and they'll take their atomic number and put it on bottom. For hydrogen, this one right here will just be 1 and 1. For this one, we'd have an atomic mass of 2, and then we'd have the atomic number of hydrogen 1. For the third one, we'd have atomic mass 3, and then we'd have atomic number 1. So all three of them are hydrogen. They all have 1 proton, but the neutrons change. And see, the mass is all in the middle. So when our neutrons change, it's going to change our mass. This one is going to be much heavier than this one. This one's mass is 3, that one's 1. So let's do an example here. You'll notice we have atom A, and you can see exactly how it looks. Atom A has 3 protons, 3 electrons, 1, 2, 3, and we said it had 3 neutrons. How did we find that? We took the atomic mass, 1, 2, 3, 4, 5, 6, minus the protons or atomic number, 1, 2, 3, and we get 3. You could also find the mass by counting up the entire contents of the nucleus. So this is going to be lithium-6. Now, how do we know it's lithium? Because we know that there are 3 protons. Atomic number 3 is lithium. So it has to be that. Protons will always be your atomic number. So let's do this one. This one, if we look at it, atom B has 3 protons. So I know it's still the same element. I can go ahead and go down here and I can put lithium. I'm going to have to come back in a minute and write the mass out to the side. The reason that number is always the mass, by the way, is because we already know what the atomic number of lithium is. It's always 3. We don't need to tell you that again. So when they write a number out to the side, that is telling you the mass of that atom. Number of electrons, I count 1, 2, 3. Notice these two are the same. So they obviously are going to be neutral. And neutrons, I've got 1, 2, 3, 4. Okay, I've got 4 neutrons. So my atomic number is the same as my protons, 3. My atomic mass, though, has changed. Remember, what 2 things are in the mass of an atom? Protons and neutrons. So I've got 3 protons, 4 neutrons. So my mass is now 3 plus 4 is 7. So out beside lithium, this is not lithium-6 anymore. This is lithium-7. Okay? Lithium-7. Now let's do the same thing right here. We've got 1, 2, 3 protons. So I already know 3 protons, atomic number 3. That's going to be lithium. All right, number of electrons, still the same, because in an isotope, our electrons don't change. They're always going to be the same as your protons because we need it to be neutral. We can only change one thing at a time, okay, for this case. So we need to know the number of neutrons. Now I could go up here and I could count, and I could say 1, 2, 3, 4, 5 neutrons. So remember, in the mass, we have protons and neutrons. Those are the only 2 things that weigh anything. So my atomic number, remember, same as protons. Atomic mass is going to be protons and neutrons. So 5, 6, 7, 8. So this is going to be 8. So lithium now has a mass of 8. So if I come up here, all 3 of these are lithium. All 3 of them are neutral, equal protons, equal electrons. All that's changed is our neutrons. When you change neutrons, when you have a different number of neutrons, you have created an isotope. So isotopes are atoms with the same number of protons. For example, lithium 8 has 3 protons, but 5 neutrons, as compared to lithium 7 with 3 protons and 4 neutrons. Okay, so they both have the same protons, just different number of neutrons. That is going to always affect your mass, not your charge. Neutrons have no charge, so this will not affect the charge. All right, what I want you to do is go through these and do these on your own. If you need help, remember, you can always, here, your instructions will be off to the side, but you can always go back here and look at how we did that. All right, so your assignment will be right here under classwork. You're going to scroll down. You'll see Unit 2, Day 3. You're going to do just what I asked you to in the video. We are going to be watching this video first, and then you're going to go to your digital notebook. You're going to read through slide 22, slide 23. For me, it may be different for you. You're going to watch this video while playing the speaker. You're going to look at how we did this slide right here, okay? And then you're going to do this slide on your own. Remember to write the isotope with the mass after the name. So right here, for instance, we see 3 protons. This would be lithium dash 1, 2, 3, 4, 5, 6. Lithium dash 6. Okay, if you get confused, the directions are right here. Have a great day.